All right, this is part 3 of the video lecture on dimensioning techniques for engineering graphics. We're going to kind of start here with a review exercise on feature dimensions and how they should look, just to help you start to begin to understand the techniques and how we should do this when we're actually drawing. So in this case, we're given two looks here. And it says to indicate the size of the following features using appropriate feature dimensions. So in this case, they want to dimension the diameter of the hole, and here they want to dimension the radius. So if you think about it, there are a couple of different ways that we could do this. But since this is a hole, the easiest way is probably just to use a leader line with the actual note for the diameter size of the hole. And here in the dimensioning of the radius, kind of the same thing. So here you see the leader line being used, the diameter symbol, and then the feature size of that particular hole. On the right side here with the radius, so again, we're given the R, which is the symbol for meaning a radius, and it's again using the leader line pointing to that feature. So now it's saying to dimension the blind hole. So you got to think about, okay, so we've got a blind hole. What should what type of dimensioning or what type of line should we be using? And what should the note that would be going along with it look like? So here we go. So we're going to again use the diameter symbol with the size of the feature. And then we use this symbol that shows that it's going to go to depth of 15 on the size. So we've got that case. Here they want you to draw the whole side view. So when it's saying, all right, we've got a through hole that is 10 we'll say millimeters or 10 inches in diameter. It's going to go all the way through. So you say, how would that look here in the side view? Well, now we're going to have the hidden lines showing the tangency points up at the top and the bottom as they project over. And we also need to have the center line too. Now, it's important for you to know and understand, without this center line, the implied reference to this view is that this would be a flat feature on the opposite side of this part, or on the inside of this part, as opposed to being round. So the center line there gives us a better understanding and lets us know that that is a circular feature in this case. Now let's talk about dimensioning of the sphere and the rod. So with the spherical end. So again, to our vantage point, just looking at this, we can say, okay, what is this? Is this is this a hole? Is this some type of a cylinder? Or how do we know what the three-dimensional shape of this is? So in order to spell that out, we're going to have a spherical diameter and then the size of the feature. Over here, the spherical radius, and then the size of the feature. So spherical diameter, spherical radius. Those are the call outs or the symbols that are being used and what the meaning behind them are. So now let's talk a little bit about what the difference between circular and rectangular views are, when we should use one over the other. And how this applies to our dimensions. So in this case, you're given two views. You're given a top view and a front view, and you're asked the question, which view is considered the circular view, which is considered the rectangular view, and why would we dimension it one way over the other? So let's kind of explore what they're trying to tell us here with this. And you can kind of clearly see up here, because of the two views, we've got a hole here, and we've got this type of cylindrical hub that's projecting out from the top of this part. Now, just looking at this, we can't really tell what the whether these are both holes or whether they're both projections like a Lego block, or what's going on here. So this is where we're saying, all right, well, this is the circular view because it's showing the actual circle, and this is what our rectangular view is. And we're going to use this idea of circular views and rectangular views to kind of call out and place dimensions on it. So let's kind of go through here and take a look. So the question is asked, why do we give the diameter of the hole in the circular view and the diameter of the cylinder in the rectangular view? And again, the idea is here so that we don't confuse the difference between a cylinder and a hole. Now, in general, on larger prints, of course, this is kind of a very specific drawing here to kind of indicate and emphasize this feature. So on larger parts and larger prints, there are some other things you're going to start to learn how to tell. But in general, bear in mind if it is a circular feature that we're looking at, and if it is not a projection, so we're going to kind of put the hole on the circular view and the cylinder in the rectangular view. So as we talk about holes, notice it's saying here that we give their diameter and location in the circular view. So we know the position here of this. So we've got the 20 diameter 20, and we're given the vertical dimension and the horizontal dimension to locate and let us know exactly where the center of that hole is. So now we're also locating the cylinder in the same way and in the same view, but we do come down to the rectangular view and give it some more dimensions, the actual linear dimensions down here to help us to understand that that truly is a hub or cylinder as opposed to the hole. So let's kind of go through here. The next symbol that we're talking about is this X, which is used to emphasize a number of times that a feature is going to be repeated. So note that there should be no space between the number and the X, because a space between X and the dimension should also occur. Now, we'll talk about there is a different meaning between 8X and 8 space X. So we'll talk about what the difference in that meaning is here in a little bit. So here is an example showing, so we've got the reference dimension or the spacing, so it's saying 15 is the distance from center to center, and we want 10 spaces. So 10 spaces, so 10 times at the distance of 15, which is going to give us a total distance of 150. So, and notice that will actually give us 16 holes as we take a look at this. So here's another example and a arc. So a hole feature that's on kind of a bolt circle. It's saying 6 times 15 degrees. So or 6 times 15 degrees. So if you take a look at it, all right, we've got 1, 2, 3, 4, 5, 6, 7. So it's going through a 90 degree from here over to there is 90 degrees, and we're going to basically have 7 holes. They're spaced at 15 degrees apart. Now let's kind of count that up. So this would be 15 degrees, 30 degrees, 45 degrees, 60 degrees, 75 degrees, and 90 degrees as far as the placement of those holes. So as an exercise here, fill in the repeated pattern dimension if there are a total of 11 holes all equally spaced. So as you kind of come back and do this, so this would be called out 10x, no space, and then 15, which will equal 150. So sometimes we have some space restrictions, so we can jog the dimension lines here as well. So I don't see that too often or too frequently on prints, but that is an acceptable method as well. Now we're talking here about solid parts with rounded ends or slots or grooves. Again, this also can kind of say, as we're looking at it, this can again be a slot that is cut out of a part, or it kind of might project up and be some type of a hub on top of a surface as well. So we'd still kind of call these out both ways. Again, here now, notice, so we're saying 2 times the radius. Now, we are also not calling out the radius here. So why don't we call out the radius here? Well, predominantly because, again, we know what these tangent points are. And if we know that that dimension from the top of the slot to the bottom of the slot is 10, then we know the radius automatically is 5. So we avoid redundancy here. So we don't need to call out the physical radius. We just are saying, hey, there's a radius there. And it correlates with this dimension. So over here, because we don't have a full 180-degree arc, this is a cut across. So here we do spell out and put a actual value for the radius. So in this case, we're saying we have a radius of 7, and that occurs 2 times. So both here on this side and there on that side as well. So overall, when we're talking about slots, so we do 2 ways that we can give the dimension, depending again on what you're trying to say. We can go from one end to the other and give that dimension. And of course, the width of that. So we can say, all right, we've got a length of the slot from end to end and a width of the slot here. Or we can dimension it down here, where we can also say, all right, in this case, the length of the slot goes from center to center, and again, the width is the same dimensioned wise there. So 2 different ways that we could dimension this. Sometimes it really kind of depends on what you have spacing for, or really what is more important on some of these different features. So let's talk about doing this exercise. Again, it's saying dimension these 3 solid parts or dimension this slot. So what should it look like? I want you to take a minute right now and just kind of think about how this should appear. So as we take a look at this, so here are 2 acceptable dimensioning styles for the slot. So now it's asking us to do the same for this slot. So this would be an acceptable method. So, and now it's talking about the dimensioning the length of an arc. Now notice how we have this symbol along that size of the feature. So, and that lets you know that the size of this is an arc because of that arc length symbol. So, if the part is symmetric, we've got another line type here that we need to be aware of. So notice the symmetry line and how we have these 2 perpendicular tick marks along the symmetry symbol line. So now that means that the feature is the same. So we don't need to dimension this size as well. We can just use the line of symmetry, and that automatically lets everybody know that this hole is going to be kind of placed at the exact same location on that side that it is on this side. So it saves some dimensioning time.